Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 46, CI/CD Pipeline Security. Alice, last episode we talked about hardening the containers themselves. Now we're talking about the system that builds and deploys those containers.
Right. CI/CD, continuous integration and continuous deployment, is the automated pipeline that takes your code, builds it, tests it, packages it into a container, and deploys it to production. Every time a developer pushes a change, this pipeline runs. And here's the thing most teams don't think about. This pipeline has access to everything: production database credentials, cloud provider keys, container registry tokens, deployment permissions. It runs arbitrary code, whatever's defined in the pipeline configuration file. It is the most powerful system in your organization.
And I'm guessing it's not treated that way.
Almost never. OWASP, the Open Web Application Security Project, published a dedicated top 10 list just for CI/CD security risks. Their assessment is blunt. These pipelines are the most privileged systems in most organizations' infrastructure, and frequently the least hardened, least monitored, and most credential-dense environments. That's a dangerous combination.
Right. So what does an attack on a CI/CD pipeline actually look like?
Let me describe the most elegant version. It's called poisoned pipeline execution. Imagine your legal SaaS platform uses GitHub Actions for CI/CD. Every pull request triggers the pipeline. Run tests, build the container, deploy if the tests pass. An attacker submits a pull request. They don't even need to change your application code. They modify the pipeline configuration file, or a build script, or a test file that the pipeline executes, and inject a command that sends every secret in the pipeline to an external server. When the pipeline runs, it executes the attacker's code with full access to your secrets.
That's not attacking the application at all. That's attacking the build process.
Exactly, and it's devastatingly effective. In March 2025, attackers compromised a popular GitHub action called changed files that was used by over 23,000 repositories. Every pipeline that ran that action executed attacker-controlled code. The secrets, cloud credentials, deployment keys, registry tokens were exfiltrated silently. Your own deployment process delivers the attack.
That's sobering. So how do you defend against this?
Multiple layers. Let's start with secrets. Never, and I mean never, hardcode a secret in a pipeline configuration file. No database password in your workflow YAML. No API key in your build script. Use your CI platform's native secret management. GitHub has encrypted secrets. GitLab has masked variables. These inject secrets as environment variables at runtime and redact them from logs.
Yeah, but is that enough?
For production credentials, no. Platform secrets are a reasonable baseline, but they're available to any code that runs in that pipeline step. The better approach is to integrate with an external secrets manager. HashiCorp Vault, AWS Secrets Manager, or your cloud provider's equivalent. The pipeline authenticates to the vault, retrieves only the specific credentials it needs for that specific job, and those credentials are short-lived. They expire after the deployment completes. Even if an attacker exfiltrates them, they're useless within minutes.
What about the poison pipeline problem? How do you stop someone from injecting malicious code into the build?
Branch protection. Your main and production branches should require pull request reviews before merging. At least one reviewer passing CI checks, no direct pushes. This means no single developer and no compromised developer account can push code straight to production without another human reviewing it. You should also require signed commits, which prove the author's identity cryptographically. And dismiss stale reviews. If a developer pushes new commits after the reviewer approved, the approval is invalidated and re-review is required.
Right, that stops a compromised account from slipping something in after the review.
Exactly. And there's a subtlety here for pipeline security specifically. Even with branch protection on your main branch, The pipeline configuration itself might be modifiable through pull requests. Some CI systems will execute the pipeline config from the pull request branch, not from the protected main branch. That means the attacker's modified pipeline runs before any review happens. GitHub Actions handles this through workflow approval requirements for first-time contributors and through the pull request ticket event, which runs the workflow from the base branch. Check your CI platform's documentation for this specific scenario. It's one of the most common misconfiguration gaps.
Ugh. Let me ask about the output side. The pipeline builds a container image. How do you know that image hasn't been tampered with between build and deployment?
You sign it. Sigstore's cosign tool provides keyless signing for container images. Keyless means you don't have to manage a long-lived private key. The pipeline authenticates with its existing identity, gets a short-lived signing certificate, signs the image, and the signature is recorded in a tamper-evident transparency log. At deployment, your orchestrator verifies the signature before running the image. If someone replaces the image in your registry with a backdoored version, the signature won't match and deployment is blocked.
Yeah, that's like a notarized document. You can verify it wasn't altered after signing.
Good analogy. And this connects to what we'll cover next episode: supply chain security and build provenance. The idea is not just that the image was signed, but that you can prove what source code it was built from, which build system produced it, and that no one tampered with the process.
One more thing, pipeline service accounts. The identities the pipeline uses to deploy, are those typically well scoped?
Almost never. The pattern is depressingly common. Someone sets up the pipeline, gives the service account admin access because it's easy, and moves on. That service account now has permission to destroy infrastructure, delete databases, modify IAM policies, none of which the pipeline needs. The principle of least privilege applies here as much as anywhere else. A build job needs read access to source code and write access to build artifacts. A deploy job needs permission to push to a specific container registry and update specific services. A rollback job needs to update services to a previous version. None of them need admin access. Scope them tightly.
Ugh. And for a legal SaaS team building a case management platform or a document review tool, this pipeline security is directly protecting client data.
Directly. If your pipeline is compromised, the attacker can deploy whatever they want to your production environment. A backdoored version of your contract review tool that exfiltrates client documents. A modified authentication service that gives the attacker admin access. Your clients, law firms handling privileged communications, would never know until the breach is discovered. Pipeline security is client data security.
Strong point. Next episode, supply chain security, SBOMs, dependency scanning, build provenance, and what SolarWinds and XCU Mills taught us about trusting the code we didn't write.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.